Okay, number 2. Salt cedar trees in riparian areas of Arizona can transpire up to 4 meters of groundwater over the period of a year. If this maximum rate of transpiration occurred along a riparian area that is 10 kilometers long and 3 kilometers wide, what is the annual groundwater loss in cubic meters? And if this transpiration can be reduced by 50%, how many people could be supported with this water over a 1-year period? The freshwater use per capita in the region is 8 cubic meters per day. So the first thing we're going to do is calculate the area in square kilometers. So we are given the length and width of that area. So it's 10 kilometers times the 3 kilometers. And that gives us 30 kilometers squared. So that's the first part of the problem here. But then we need to convert this into the square meters that it's asking for. So to do that, we just use this conversion here. So 1 kilometer squared is equal to 1 million meters squared. So multiply those two together. And that is going to give us 30 million square meters. Then we're going to calculate the volume in cubic meters. So here's their area, and we just need to multiply that by the 4 meters of groundwater that the trees transpire. So times 4. And then that's going to give us the 120 million cubic meters. Okay, calculate the volume equivalent of 50% reduction. So we need to cut this number in half. So this, and then we'll multiply that by 0.05. And then that's going to give us 60 million cubic meters. Oh. Okay. So let's calculate the required volume of water per year. So we know that we have the 8 cubic meters of water use per day. And then we need to multiply that because we need to find out per year. So I think some of you missed this step when you submitted the problem set 1 the first time. So we'll just multiply that by the 365. And then that gives us 2,920 cubic meters per year. So that's the annual water use per person in this region. So what we want to do is we're going to take this number. So if we're able to stop the trees from using this much water, how many people could we support? So we're going to divide that by the annual water use for each person. I hate when it does the superscript when I don't want it to. So I'll give you a second to calculate that out. And what you should get, if we're all doing our math right, is 20,547 people. And we shouldn't round up just because we don't do portions of people. All right, that one was pretty simple. And again, let me know if you have any questions.